All right, hi everyone. We are here with favorite trees to be coded today, and there's also other interesting stuff that we'll be talking about. Well, I'll be sharing the screen when I'm coding, and there's one small problem though. I haven't coded favorite trees earlier, so it's actually on purpose so that when I'm coding, I feel all the weird things that you'll probably encounter when you're coding for the very first time, favorite trees. But it seems simple. And so I started off about half an hour ago, and I have coded a little bit, just the primary data structure. So yeah, till now, that's the only thing that's happened. So I'll just share the screen with you now so that things get better, and I'll just put it a little bit down there. So that's the board that I work on, by the way. Just a little bit of information. That's a nice board right there. And let's start with favorite trees. So here's my screen. I'll just share that. And we are in the code. Okay, so what do we do? Well, you see that I have, what have I done? Yes, I have a favorite tree class. I also have a node class. So node is an object in every favorite tree. You have a set of nodes, and each of these nodes is basically the subtree that I was talking about in the previous lectures. You have an array of values. You have the left counts and the right counts. Right counts can be evaluated using the left count only. You have min and max in that array, which tell you what is the middle of that array and therefore what is the pivot value. And you have left and right. I'll just do one thing. I'll just have a look if things are going smoothly. So I'll just minimize this. And here's the thing. I'll have a look at things are going smoothly. And if I'm audible and stuff like that, So a lot of fear. Yo, hi, bro. Hello, bro. Are you placed in any company? Yes, I am placed in. I'm placed in what? Yeah, I'm placed in DirectEye. So that's the place where Code Chef is working. So yeah. So yeah, but yeah, that's right. Neat. Thanks. So let's get back to wavelet trees again. So we have the left and right nodes, and these are going to tell you the left and right subtrees. So the way that I'm constructing this wavelet tree is actually very nice, according to me. You have a node, and each node is going to need an array and the size of that array in 10. So what I'm doing is I'm just copying that array into the array value, the field value you have here. You also have the left counts that you have. So those will be initialized to the size of the array. Okay, that's what we need. And then we have maximum and minimum value, which we find through this code. So this is just iterating over all the elements, just checking if the maximum is less than what we have right now, and then setting that. And similarly, minimum is set if that's the smallest element. So these things are pretty simple. Left and right will be created actually in the end. I'll just show you first. So left and right is created by taking the left subarray and the right subarray with the counts that you should have at that point. So the left subarray count at the very last point is the number of elements which have gone to the left till the very last point. So this is how stuff happens here, and this is basically mapping the right index, the rightmost index in this array, right array. So before we get into that, actually, probably we should talk about left count. So left count counts the number of elements, including this element. Okay, this is important because in the previous videos I talked about excluding the element, but left count counts the number of elements, including this element, which have gone to the left array up to this point. So left count of I tells you the number of elements in the left subarray, including this point. Okay, and the way we actually make sure that this works is first we see if this is a leaf node or not. So max and min are set to these values, and isLeaf node is a utility function which just says if the minimum is equal to maximum, there's just one element in this entire subarray in this entire array, and there's no point actually building the left and right subtrees. So those will be null. That's what they're being assigned to. Now you also have middle, which is the pivot element. So I can call this pivot. I think that will be a better name. One of the strange things about this code is that it's not tested at all. It's tested by using public static void main, so that's not really a test. So in any case, so you have the pivot, you have the left array and the right array initialized to these sizes of n, although they can be smaller, but I want to do this in just one shot, therefore I initialize them to size n, and we can then get our stuff done. So if this array value, if the element at the very first index is greater than the pivot, what we do is we put it in the right subarray, and we don't need to update left count because the number of elements which have gone to the left up to this point is still 0. Okay, and if that's not the case, then well, left array needs to have this element, and left count of 0 is set to 1. Okay, this gives us a preliminary understanding of what happens in the loop. In the loop, from the first element, what we are doing is we are checking if this value is greater than the pivot, and then putting it into the right array if that's the case. Okay. Similarly, we are putting it into the left array if the pivot is less than or equal to, rather greater than or equal to the value that we have right now. And then left count is, suitably modified. If it's going to the right, you don't really need to modify left count, so nothing happens. It just takes the previous value of left count, I minus 1. And if it is going to the left, then it has to be added by 1. So that's exactly what's happening here. So pretty logical stuff till this point. I'll just talk about some utility functions that you have in this data structure. So that is min is equal to max, then it's a leaf node. You can get any element, you can get the left subtree, right subtree, all right. Getting the mapping on the left and getting the mapping on the right. So getting the mapping on the right is a little interesting. You take the index and just remove the number of elements which have gone to the left up to this point. That tells you the mapping on the right. And get element on the left, and these things, I don't know if I'll use them, but I've just kept them because I really don't know what will be end up being used in the end. So finally, what I did is I tried to test this, whether it even initializes by just creating an object of Wavelet tree and passing this as the array. So 10, 10, 1, 17, 4, and 6. Let's see if things work out. So I'll just zoom this in. So you see that the array is over here. Left count is 0, 0, 1, 1, 2, 3. So this is correct. Up to this point, it's correct. 1 and 17 is also correct, minimum and maximum values, because 1 is the minimum value here and 17 is the maximum value you have. In the left node, what should then happen is 1 plus 17 by 2 is the pivot, which is 9. So anything less than or equal to 9 should go to the left node. And that's exactly what's happened, 1, 4, and 6. So the right node will have 10, 10, and 17 in the same order. Yeah, thank God, it's not sorted or something. So left count then in this array, okay, this is weird. What's the minimum of this? So the left count in that array is going to be 1 and 6, 3.5 is the pivot. 3.5, anything greater than 3.5 should go to the right. So initially you have 1 being placed to the left. Yeah, that's perfect. And now, okay, so when you have 1 placed, it's just 1 element, and therefore that takes care of things. Yeah, that's a leaf node here. I'll just have a look whether we are at the same page. So why Java? Okay. Can Wavelet trees replace segment trees? Yes, they can. In fact, Wavelet trees are sometimes better than segment trees when I'm talking about persistent segment trees. So segment trees in general are not as powerful as Wavelet trees sometimes. You need persistent segment trees to answer some complex queries. What then ends up happening is you end up using persistent segment trees which are not the right data structure, at least logically, to use. So if I give you the question m kth num, and you solve this using persistent segment trees, that's one way. But really, the right way to do it probably would be Wavelet tree, because they're designed for that kind of question. And one final thing is that you can also do updates using Wavelet trees. We haven't gotten to it yet because let's code it and then see if things work. But updates are possible. Some simple sort of updates are possible, and that cannot be done using persistent segment trees. So this is, in some ways, a more powerful data structure than PST. So it's one thing. And what's okay? You want a quick walkthrough of Wavelet trees? All right. Does anyone else want that? And I'll just go through that, of course. Well, Wavelet segment tree, all data structures are only modifications to apply to get what is desired. Yes, that's true. That's why we do this. So hey, okay, C++. That won't be possible because, okay, Dhruv, C++ is the request. Fine, I'll just have a look at this. I'll probably have to learn C++ and be very comfortable with it to go live talking about it. Therefore, yeah, but let's see if C++ happens. I don't think it's likely, so I won't try to put any false hopes or anything. Java is something that I'm comfortable with, and you know, if you can contribute code with C++ later on, that'll be great. So most probably I'll just be sticking to Java because that's what I can talk about and explain very comfortably. So for now, Java. Right. So getting back to the code, we see that things are going well till now. 4 and 6 is going to the right. That makes sense. 3.5 was the pivot. My God, my memory is so perfect. So over here, the pivot should be 5. 4, yeah, that's the left element. And then the next one should be 6. Perfect. 10, 10, 17. Okay, yeah, that makes sense. So 10, 10, 17, and we have 10 and 10 should go to the left. Yes, that makes sense. Yes. So things seem to be going well. I wasn't expecting this, to be honest, but yeah, things seem to be going pretty well over here. What else? So I have these functions for the Wavelet tree, which is rank, quantile, and range counting. Okay. Rank is like we discussed. Oh yes, of course. A quick discussion of what Wavelet trees are. Wavelet trees are data structures which help you answer queries like finding the kth largest element in a given range. Okay, and you have many queries. So mkth num is actually the perfect question for Wavelet trees in many ways. Another kind of answer that you can give is how many elements having value, this value, elements having value x, exist in the range left to right. If you have many queries like that, this is a data structure which can answer that very easily, all right, and very well. So all of these are log n query times, of course. And range counting, this is actually one of the most complex range counting stuff that happens in competitive programming. If you have A to B indexes, and if you have, that's A to B over here, A to B indexes, and if you have C to D element ranges, find me the number of elements having values between C and D in the range A to B is a pretty complex query. It can be solved using persistent segment trees, but Wavelet trees do it much more elegantly. And this data structure is designed for that again. The applications of Wavelet tree is huge. So I'll just get to the internals of it. What it does is it keeps a mapping of every index in this array that it has. So internally it stores an array, and it keeps a mapping of every index in that array to the left and to the right. Okay, and for now, just understand that these things happen. Probably you can just go through the code and that'll help you understand better. But yeah, it has an array. Each node, it has a set of nodes. Each node has an array. It has a way to map those indexes to the left and right children. And of course, it sends people to the left or to the right, depending on the middle value of those elements. Okay, so that's a quick walkthrough. I hope that suffices. Okay, I hope koi stack. Yeah, I have that actually in the huge list of algorithms that I'll be working on soon enough. So next probably, yeah, well, we'll get to that later. First, let's complete the Wavelet trees. Okay, so we need to find the number of elements. Rank is an operation actually, so I'll just write this down above. This finds the number of elements in the given range having value equal to element, right? That's this, and the range is defined by the left and right indexes. Okay, so remember we talked about left index and right index being mapped to particular indexes. So, well, how do I do that now? Okay, the first thing I need to do then is to go to the root. That much is certain. So in the root, what I need to do is find the rank of this element in this range. Okay, fine. So what I really need to do then is find the number of elements in this range. Well, I have completely forgotten about rank. Well, you need to find the element here and the number of times that it occurs. Okay. So what do we have? We have the number of times it occurs. So we need to get to a leaf node. Yes, that's right. So what do we need to do? We need to find this element first of all. Okay, that's great. Right. Right. We need to just find this element in that range. So what we are going to do is we are going to go to the left subtree, check if the range of elements is containing this element, and if that's the case, then we process it further. Otherwise, we go to the right subtree, don't we? I'll just get back to you guys and tell me if you guys are helping. Okay, fine. I have to do this all by myself. All right. Left index and right index. So firstly, find all elements in left subtree having element in range. All right, and do that for the right subtree also. Once you have this, all you need to do is just add up those things. Okay. Ah, yes. No, we don't need to do this actually. You know what? We can find the pivot. We can find the pivot at this particular position. So root has a pivot, right? I think get pivot is a utility function that root should have, or any of these guys should have. So this will be in, and what it's going to do is it's going to be keeping min plus max divided by 2.0 as the pivot. Okay. Of course, this is weird. Yeah, this is divided by 2.0. Okay, min plus max. All right. So I'm going to take the pivot by taking the min plus max divided by 2. So that's the middle of the range of elements that we have. All right. So this is the pivot of the root. So what I need to do now is find if the element I'm searching for actually is greater than the pivot or less than the pivot. But depending on that, I can say whether I need to go to the left or to the right. So this is pretty obvious. I don't know why I didn't remember it, but yeah, this is simple because I have the pivot. If my element is less than or equal to the pivot value, then life is good. I need to go to the left subtree. And otherwise, my life is still good. I just need to go to the right subtree. Okay, both of them are login queries, so we are pretty happy with what we have done. Now, if we go to the left, what we need to do is we need to map these two guys and then rank them. So here's the thing. So the root is probably going to be a general element. Okay, you start off at the root and then you keep going further. So root then becomes root dot left, right? Unless, of course, root is, or we'll call it something else, but root is a leaf node. Then we need to do something else. So this won't be root, this will be node. Now, if the node is a leaf node, then we are done. Okay, because between the left and right indexes, we need to just return the elements right index minus left index. So between 4 and 4, there will be one element. So this will be plus 1. Okay. So if it's a leaf node, then you just return the number of elements between this range, which is basically the size of the range. If it's not a leaf node, then you check if the element is less than the pivot. So I think this should also come down. That makes sense. If element is less than the pivot, then we go to the left node. Otherwise, we go to the right node. So are things clear now? Okay, lots of questions. I'll just quickly go through them. Surge and commands. Okay. Who said Java is dull? Well, that's fine. How's it better with segment trees? Okay. Yeah, well, I'm completely language agnostic. So if you say Java is dull or C++ is dull, it doesn't really matter. I mean, I believe that all programming languages, except probably Brainfuck or something, is very much good. And yeah, so we are back here with node, which is get left subtree, get right subtree. Uh-huh. So we have changed the node, but before that, probably we should do something else. We should check the number of elements in the left node. No, well, we of course need to go to the left. Do I need to do anything now? This should be a while loop, of course, but before that, let's just have a look. We go to a node, we check if this is leaf node and return. And then we see the pivot. If the pivot is so and so, then we just, okay. Now, if it's a leaf node and if the element does not exist, then you know what, you need to return 0 because this element does not exist. Otherwise, you can return this value. So that will take care of if it's a leaf node. Otherwise, you need to just go to the left or to the right till you hit a leaf node. So that makes sense. And now we have in a while loop. Is this going to go on forever? Yeah, I guess, yeah. So it's going to be right here. It's a terrible coding practice, by the way, while true. But yeah, it's fine. In fact, I'll just do this, right? Because I hate bad coding practices. So this is the only point you're returning from, and that should probably belong then here. So eventually you will hit a leaf node. And what's going to happen is, at that point, you'll check if it's the pivot or not. Okay. So yeah, this should work. This should work. This is so reassuring. This should work. So anyone in for giving an example on what the Wavelet tree should be or what the query should be? Dot query. Okay, let's count the number of. Yeah, well, CPP is big. Oh wow, the language thing still goes on. So right, right. So in short contests, yes, I usually try to keep as many libraries that I can. So there are self-made libraries or libraries that I use from Java itself. C++ and SQL is also very powerful. You have Python, which is of course very, very powerful as a language, but the time constraint sometimes is not very inclined towards Python. This question of Gaurav Chandra is what I'm answering. What I try to do is keep as many code segments like segment trees. So this is actually what I used to do because it's been years since I've programmed competitively, and to keep as many code segments that I could in GitHub. So GitHub is something that you can have a look at in case you haven't already. All right. GCD, well, I haven't seen it. So in range query, we store the GCD of children in segment tree. How would you do that with Wavelet trees? Well, segment tree is an aggregation operation. Every node has some sort of aggregation operation. And what ends up happening in that is sometimes it's much better, I think, to have a segment tree. But I'm not sure if augmented Wavelet trees can't do that, because I really don't see a reason why that wouldn't happen. For example, even the GCD, I mean, as long as you have the elements all put together in the same thing, so GCD of them is going to be 1. And no, I think, yeah, it's going to be a slightly more complicated. So yeah, it's a good question. For GCD in range query, we store the GCD of the children and stuff. So that's a good thing, actually. Segment tree seems to be holding the aggregation of the children, while Wavelet tree seems to be holding some ordering properties. All right, so that's cool. But let's get back to finding a rank query. So first thing that I can do is just go for this guy. Yeah, that's an array. And a.length is what I'm looking at. So rightmost index probably. And this is going to be the element 10. Okay, so what I want this to print is 2. Now, let's see if that works. 6, wonderful. How very nice. So what it's done is it's just picked up the whole thing, the whole array. Fine. So why did that happen? So once we get here, we see if it is not a leaf node, then go ahead and do this. So what it's done is it's found a leaf node at the very first point. That's weird. If minimum is equal to maximum. Okay. So what I'm going to do is I'm just going to print out the node here because I don't believe in JUnit. I have this weird thing about using SOPLM, but one minute. Node of array. Why did it print out twice? That's very odd. Okay, so actually it's gone to the left and to the right, and to the left and to the right. And that doesn't make sense. If it's not a leaf node, yeah, well, fine. So at the left node, it found, going to the left, it found something. So one thing is it should go to the right. Yeah, well, this is the right node, what I'm saying. So this is the right subtree that it's gone to, and that's how it should be. And then what it's done is it sort of printed out the whole thing. But what it should have done then was go to the left node again, because 10 is to the left of that. And why didn't that happen? Because this has come out to, okay, one minute. First of all, this is wrong, because right index minus left index is not going to be the answer. What I need to answer is the size of this node. It's actually node dot get this size. Basically, I want this size. So I think I'll just put that as a utility function again. So get size is one of the things. I'll just put a method get size. Is there something odd here? No. Yeah. So get size. What's it going to return? It's going to return n. I can just store that actually. But a better way would be to use the, I don't know if it's better, but yeah, leaf count length. So I don't need to actually specifically store the size. Now let's again run the query. 2 is the answer. Great. Just zoom that so that you believe me. 2 is the answer. Now let's try to improve this by just putting 1. Okay. 2 is still the answer. That's terrible because that shouldn't have happened. So yeah, the good news is I can see the left count here itself. 1. What is the mapping going on like? What I can do is go to the rank query, and instead of printing out the whole node, right, I can just print out what left index and right index is. So IntelliJ has saved me some hard work because what's happened here is that left index and right index are not updating themselves. Yeah. What I need to do is actually update these indexes also, of course. So going to the left subtree, the left index is going to be mapping on left up to the last element, and right index, no, not exactly last element, but left index, and right index will be getting the value of the left subtree right index. So it's almost the exact same thing here. What we are doing now is finding the respective indexes on the left or right subarray. Basically getting mapping on left. Here it will be get mapping on right. So here you're checking on the right subarray, the indexes of left and right, and setting them correspondingly. So let's just run this again, and we have the answer of at index out of bounds exception. Why is that? 5. That's weird. So get mapping on right is being called here. Being called from this point. Get mapping on right with the right index. That's all, because right index should never exceed bounds. Unless, of course. No, that shouldn't exceed bounds. So right index, how did it? It said that left count of I is out of bounds. Okay, Uncle Shurmani seems a little upset. Um, a CF virtual contest. Yeah, that seems like a good idea. Short contest. I think I'll be picking up problems from CF, but to be very honest with you, whenever I have worked with Code Chef, and I was talking to Rachit Jain just yesterday, sometimes the community in CF is very particular about who should be making editorials, and they seem to not be very friendly if you actually come up with a new editorial on a problem. So yeah, that's just a problem with the game theory system, I think, over there, because Code Chef actually penalizes you for downvoting questions, or they expect a particular amount of reputation. Now, Code Forces, on the other hand, has no such thing, and anyone can technically just go and download someone. So that's pretty demoralizing after a certain point of time, because these videos, I mean, when I go out to market them, to tell as many people as I can that, hey guys, if you want some help on this particular topic, here's the thing. Um, what ends up happening is you get some negative feedback, and that really that's okay, but it's not some negative feedback. It's almost like the entire community just says that no, you shouldn't do this, and yeah, so that's pretty much the reason I've kept CF aside for now, and I'm focusing more on sites like CodeChef and Coding Game. But yeah, I think I'll get back to CF very soon once I have my morale up again. So, well, they are good coders. So the Russians, but it's not just the Russians, of course. This is not a particular country. I'm sure the entire community as a whole is quite nice, but I think the people who join new, they tend to have a little more freedom with the downward button, so it's pretty fast. So yeah, getting back to the problem now. An index out of bounds exception. Hmm. Now 133 is the line number. Of course, the index out of bounds exception is here. So 5 was a problem here. Why was 5 a problem here? Left count is actually of size 5. Left count should be of size 5. So why is that ever a problem? Get mapping on index, and then we have, so this happened just once. We went to the right subtree. Okay. Okay, no, so here's the mistake. We can't go to the tree before we have the mappings of that tree. So yeah, this is fine. So the node being updated was not being done right. Yeah. Well, even now it's 2. Okay. At least we have an understanding about why this is happening. Now is node dot get size the right thing? Nope, it isn't, because what I'm supposed to do here, so I just change that. Left count dot length is fine. I can probably, maybe I'll use the size thing, but yeah, right index minus left index, we are back to the same thing again. Plus 1 is going to be the answer. Hopefully. Yes, that's it. That's 1. I'm so pleased with myself for getting these simple things right. But yeah, that makes me really happy. Now, what I'm surprised about is why didn't it go to the left subtree and print out the child? Okay, that's because I have this thing over here. So that should have a different effect. Okay, it's even more weird. Okay, of course, if while is not true. So yeah, things are as expected. Because it's going to not go into the loop the final time. I try to put it up, but it's not a do while thing or anything. So that's fine. So, well, at least the answers are correct. Now let's try to reduce the range from the right side. Let's try to make this -3. So a dot length, I'll just give this as 6 because things are simpler. So a dot length, and what I'll try to do is evaluate this. Complete constant, yeah. So 1 to 3, and this should give me from 1 to 2 and 3. So between these indexes, I need to find the number of tens. That should still be 1. Yeah, that's still 1. Okay. Now between 2 and 3, I want to find the index, and this should be correct. Oh, wonderful, it's wrong. So between 2 and 3, the answer should be 0. But what I have is 1. One of the things, of course, which is very odd is that I'm actually in the rank, method here. What I'm doing is I'm actually adding 1 to whatever this is. That feels odd. That's odd, but what can we do about it? Well, if element is not equal to pivot, you just return 0. Yeah, so that's how stuff should be, right? Well, no. It went. So let's try to understand what happened. We went to the left. We went to the right, rather. Then we went to the left. It was a child node, so we are happy now. We come out of it. We say that is the pivot, which is equal to 10, not equal to the element? Of course, that's not true. So what we are going to do is just return this. Yeah, we are, which is weird because this is going to be 0. Okay, and I'll just print this out to make it'll make more sense then. This is going to be 0 and this is going to be +1, so that will be 1. So the answer will still be wrong, which means the previous answers are also perhaps wrong. Yeah, or is it? Hmm. Okay, okay. So here's the thing: if none of the elements have been mapped to the left, what index would you give that element? What index would you give that element? Would you say 0? Would you say it should be mapped to 0? So I'm thinking about this node here, 10, 10, and 17, and then finally 10, 10. What's happening is that the left count is 0, 0. That's fine. But what's striking me is that in the first array from 2 to 3, which is basically these two elements, so I'll just zoom in. These two elements, 1 and 17, is what we had. When we map that to the right, this thing comes up to this point. Okay, so that's index 2, let's say. Uh, this element again hits index 2, which is weird. But even more weird is that when we are actually at this point and we want to map left and right, both indexes will hit this point. So should it be this point or should it be one ahead of it? Hmm. It's a little tough question. I like your suggestions. All right. Okay. So we can perhaps get a hack out of this. I'm not entirely sure. Uh, because this is fundamentally hitting our Wavelet tree assumption that we have the number of elements which have been mapped to the left up to this point. We have the number of elements which have been mapped to right up to this point. And what's happening is that we're coming to the leaf node and we are seeing that, well, this is made out of tens. That's great. What we're going to do is we're just going to return the index. And what ends up happening there is that we actually have no elements here. We are both here. And we just say +1. So that's weird. Should it be +1 again? Let's just get back to +1. And let's just return left index minus right index. Okay. Now, logically, what happens? If we were at these 2 points, this maps to somewhere over here. Should be mapping to somewhere over here. This should be mapping to somewhere over here. Okay, but instead, what's happening is this is mapping to this point, and this is mapping to this point. Okay, and if you had more elements here, in fact, you would still map to this point and return 1. So that's something that we need to consider. And in fact, how do we get rid of this? Because this is fundamentally an issue. Hmm. What we can then do is say that on which side of this element does it exist? On which side? Yeah, so if 17 actually belongs to this array, okay, we can say that it's to the left of this element. Otherwise, if if it doesn't belong to this array, it will be on the right side of this element. Now, how do we logically code that out? What I'm trying to say is 10 exists starts from this point. Okay. Mm, yeah. Hmm. Okay. I'm not entirely convinced that what I've done here is correct. What I could have done was find the number of elements of this value 10 up to a particular point. So that would be the right index. And I could have done the number of elements up to a particular point, which would be the left index, and then just subtract them. So that would have been, easier to code. Right. Actually, that's how we are supposed to do it, and actually that's how I explained it in the previous videos. So why I ended up with this approach, I'm not entirely sure, but yeah. Yeah, I think that computer's hanged. Wonderful. Um, so guys, just give me 2 minutes if you can hear me. My computer's hanged, and I need to actually get this sorted. It's not because the question isn't working, it's just that the computer's really, really hanged. So I'll just get back in a few minutes. Okay, I think we are back. Yeah, yeah. So great. I'll get back to screen sharing, of course. And yeah, no more Hangouts. No wonder they call it Hangouts. So my computer hanged. I'm not sure if it's Hangouts' fault. I don't think it is. It can't be. So it's because Wavelet trees are so complex, Now, where are we? Yes, the rank. And there was something wrong going on, of course. Yes, fundamentally wrong. Yes, which meant that we were either putting the element to the left or to the right. Now, how do we get that corrected? So one of the ideas is to actually check if the element is towards the left or to the right. Yeah, well, we ended up saying that in the video, the way it was explained was to find all the elements within the range 0 to right and subtract them with the elements in the range 0 to left. So that's what I'm going to do now. I'm just going to get rid of left index entirely. So left index. So one easy way to do this is just to remove it from the method itself. Okay, that's done. Now the compiler will complain and we get rid of that. Now what ends up happening is left index, right index is exactly what we want to be. Well, if the index is 0, then we are going to be doing 0. So this is going to be right index plus 1. Okay, so that's pretty much it now. Documentation is it. So up to this index, in fact, so up to this index, we find the number of elements in the Wavelet tree. So that's what this question is doing right now. And yeah. Now finally, the thing is we don't want to send the left index. What we want to do is we want to find the rank between 3 and the rank between 2 for the same element. So this can be made a utility method, in fact. So I'll just hit back to 2, create a method for this. All right, and it's going to be an int method, of course. This is right, this is left. And what we need to do is we need to find rank of right minus rank of left. Okay, of course with the same element. So right, so we are done, and perfect. This should work. So now let's see if this actually does better than the previous stuff that we had. This should answer 0, by the way. Yeah, this is 0. Perfect. That's really, really nice to hear. This should give us an answer of 1 because we are actually adding this element to the left side. That still gives us 0. Wonderful. And just to check, it's wrong, but yeah, just to check, this should give us an answer of 2. But if that gives us 0, then we know we are wrong. Okay. So this gives us an answer of 1. So we are basically off by an index of 1 approx. It's weird, but fine. So up to index 1, how many elements do we have to the in this array? That's 2. And up to index 3, how many elements do we have? 2. So yes. So okay, yes, of course this doesn't make sense. Left minus 1 is what we are looking for, right? That's what you're looking for, because you cannot include this index. You should, right? Now let's try the whole thing again. At 0, this should give us this will give us a null pointer exception now, or an index out of bounds exception rather. So at 0, if left is 0, then you know what, this thing, left elements, should be set to 0. Okay, and then we subtract right elements with left elements and return that in the answer. Okay. So this is fine. This is again fine. So I'll just get back to Wavelet main. Still an array index out of bounds exception. That's weird. So I just said that find me all these elements, and oh, of course. So all CP problems coming in now. Final int left elements, and then this is how we get it done. So it's going to get initialized just once, for sure, and yeah, it should work. Everything should work, but this way. Yeah. So the answer is 3. Wonderful. That's entirely wrong. Okay. Left -1. So this is 0. Why did it give an answer of 3? That doesn't make any sense. The elements on the right are 3. Okay, so that's wrong. That's entirely wrong. Oh yes, this is index plus 1, is it? 3. Index plus 1. That's correct. 10 should be mapped to this point, 2. No, index is just 1 for 10, which is 0. So the rank query, something is going wrong here. We're getting the right subtree, we're getting the mapping on the right, we're getting the mapping on the left. Yes, for index, yeah. How's that going wrong at all? Huh. This was working earlier. That's actually even more surprising. 3. The answer here shouldn't be 3, first of all. It is 3 because it's finding out that from this point to this point, index is finally when we're returning, right? What's the index? So index is 2 and we are returning 3. Okay. Does that make sense? No, it doesn't, because index should be 1. Fine. So we have an issue here. And why is that? Because this is a leaf node. We come here, index. How can index be 2? So the mapping is wrong. Now, if you see the left count, which is the thing that I'm trying to do here. So on the left count, what it does is it goes to the left with the right index becoming 2. So basically all these elements are to be mapped. So from 1 to 2 is the mapping that we have. Is that correct? From 1 to 2. That's wrong. The mapping is wrong. So if you have a look at these mappings, 1 to 2, because you're taking the entire range, that is wrong because you're skipping this element entirely. Right, if you're moving to the left. So how do we get this done? Left count gives you a number of elements to the left up to this point, including this point, which is odd. Is it? It might be. Actually, it is. You have all the elements to this point, including this point. So actually, this just helps you populate the elements. Actually, if you're going for querying, right, what's going to end up happening is you'll have some weird stuff. So okay, so get mapping on right. If I'm on the very first element 0, and it does exist in this array, then what I'm going to get is 0 minus 1, which doesn't make sense. Okay. Yeah, that's the entire problem. If it's I is equal to 0 and if left count of 0 is equal to 1, then this is entirely wrong. So the whole this thing is wrong. So what are the things I can do? Should I add 1 here? That's one possibility, but let's just think about this. Similarly here, get mapping on left for I equal to 0 should always be 0. In fact, it could be 1, depending on if this element has been put in this thing or not. So that's an interesting problem. How about using its previous value? That makes sense. Yeah. In fact, that's going to be the answer. If I is equal to 0, then just return 0. Otherwise, do this. And here, if I is equal to 0, and getting the mapping on the right is still easy because the mapping on the right has to be 0. Switch, no, I don't want that. I want this kind of code. I'm just using a ternary operation here. Okay, if it's 0, then return 0, otherwise return the previous count that you had up to this point, or return the previous right mapping that you had. Okay, does that make sense? Does that make sense? Yeah, it does actually. So, fine, this should work. Perfect. Answer still 3. Ridiculous stuff. The answer is still 3, which is very surprising. It comes here, it sees that left count is 1 and 2, and 2. So what it's going to do is it's just going to find the previous count. So that does not exist. So it's going to give 0 because it's trying to go to the left, right? So that is 0. And over here, it's again trying to go to the left. So it will take the previous guy. So that is 2. So from 0 to 2. Perfect. That makes sense. From 0 to 2 is where it's trying to go. And then it returns index plus 1 because from 0 to 2 you have 3 elements, but actually you had stopped here itself. Okay, so lots of coding issues coming in. We can see that the logic here is very simple, but for some reason the coding is not able to grasp that logic, which means that I can just add a 1 here, subtract a 1. It's just not able to grasp that logic. So of course we need to update our logic. So this is 2 coming here, checking if this exists. 10 and 10, 0 to 2. So 0 to 2 tells you the number of elements to the left, does it? Let's give it a shot. Okay. Now let's try 1. It's still 2. Yeah, it will be 2 because I have returned 0 from there. So this query is just not working. It's the rank query is having issues. And the issue is clear actually. You see over here, what's happened is when you're trying to count the elements up to point 0, it's going to return you 1, isn't it? Isn't that odd? Isn't that odd? You know what? I think we can actually keep a left and right side. So depending on where this element is being mapped, whether it's being mapped to the left or to the right, we can tell whether the The elements are to the left or to the right. The one strange thing though is that if it's to the right, then I shouldn't be adding this +1 to the index. Okay, so yeah, that's pretty much it. Okay, so index +1, done. So what I'm going to do now is just going to map every element to the particular index, of course. But what I'm also going to do is map whether the index belongs to this array or not. And based on that, I'll be able to tell whether the point at which this element belongs is over here or over here. It seems like mathematically I can just add 1 here if it's to the right or to the left. So that should be easier than storing values in the tree. So yeah, next is 1. So if I get the pivot is 0. Otherwise, I return index if my rightmost element belongs here. So if the index, if the old index, the element, I'll just treat this as a boolean. Boolean exists. So this exists in the array. This element exists in the array. So initially it's true. Yes, it does exist in the root array. Otherwise, so now that we are inside this loop, what's going to happen is if this element is less than the pivot, then you find the mapping on the left, and you also check if pivot is actually greater than node.get element at that index. So if that is greater, if the pivot is greater, then it belongs to the right. Okay, this element belongs to the right, and therefore it doesn't belong to the left. Now we are going for the left, right? So it does not belong to the left, and it will be on the right side of the element that we are at. So exists is going to be not true, it will be false. Otherwise, exists is true. Okay. By the code, yeah. Now on the other hand, this element will exist on the right array if you're going to the right, only when the pivot is actually less than node.get index. So after all this is done, what you're going to do is you're going to come out here, you're going to return 0 here. If exists is true, then you return, if that element exists in this array, you return index. You return index, yes. And otherwise, you return index +1. Okay. The answer is coming out to be 2 now. So let's check for other things before I start giving an explanation. Okay, right is okay. What's next? 1. Perfect. So this is starting to make sense now. What about 2? 0. So what I've done, guys, is actually just see if the element belongs to the left side or the right side of the index. Now, if I come over here, then graphically probably I'll explain better. You see this guy 17 over here. Okay, when you're going to the left, it's actually pointing to the right of this time, not to the left of this time. And similarly, if I'm coming over here at 10, it belongs to this index, yes, when you're populating. But the thing is, it's belonging to the left of this side. Okay, so elements before this 10 are somewhere over here. Elements before 17 are these two elements. Now, I'm not entirely sure if mathematically we can do this easier. There must be a way because Wavelet trees are supposed to be easy to code, but this is a live session and this is the first thing that just struck my mind. Just find out if it belongs here. If it belongs here, then you just return the index itself. Otherwise, you return index plus one. Because if you're already on the right side, then you have included this element. If you're on the left side, then you're excluding this element. All right. So yeah, well, rank seems to be working now. And you know what? We can just do this in a really quick fashion. We can find out in a brute force way if rank is working. So for int I equal to 0, I less than a dot length plus plus. So we just get the element out. Okay. And what we're going to do is we're going to actually brute force this and then try it on our tree and see if they both match. So int count equal to 0. That's initialized over here. And if a of I is equal to element count plus plus. Okay, so you have some count, and what you want to do is you want to assert if count is equal to this value, right? And if it isn't, then something will happen. So rather than do this, we want to see if count is not equal to the value that we have, then we should throw an exception. Oh, in fact, left and right are also to be taken into consideration. So left and right. What does this need? A message here. So I'm giving it a message. This is just quick debugging, guys. I think it is working, but what I want to do is before I make the claim that it is working 100%, I just want to make sure that I'm sure about what I'm speaking. So the element and everything has been put in the exception if this does happen. So new, let's say, runtime exception because Java will otherwise throw compile errors. And then what we can do is we can just otherwise just keep moving forward. So, and we are going to do this like 10,000 times, right? So. Okay, so count is over here. For the elements are also going to be randomized. So for int I equal to 0, let's just say int test equal to 0, test less than 1000, test plus plus. Okay, this whole thing is going to be checked then. Okay, and of course left, right, and count are random numbers. So no, count is fine. Left is a random number between that's going to be generated this way. I'm just going to make random dot get the next int between a dot length and 0. Similarly, this is going to be element between a dot length and left plus 1. So this is going to tell me the difference between the two lengths, and then do I need to do a plus 1? No, plus left actually. So this is how things work in Java. Now a dot length, yeah. So everything is fine. But then this is going to be 0 plus 5. So fine, everything seems fine. Now left, right are being randomly generated for each well. Yeah, I can do lots of stuff here. Wavelet tree. This needs to be random. So what I'm going to do is I'm going to store this value in new int. Let's say the size is about 1000, and for every element in I, so that's going to be something like this. randomly generated. Between 0 and 10,000, this value is generated. We are going to test whether this works. Let's give it a shot. Most probably, the whole program, the whole universe is going to explode or something, but yeah, wonderful. Why is that? Array index out of bounds at 8. I would have expected something better, but yeah, what happened? Array index out of bounds at 8. Okay, fine. Now left -1 elements. Okay, if it exists, get the element at index so and so, and it says such an element does not exist. Okay, so why would it ever go for such an element? Because the index does not exist in that array. Yes, it doesn't exist. So all right. Now exists is of course not going to exist if index is out of is equal to the size of that, or basically if index is not less than n. So that's another thing to consider. Now if index is less than n. So what I mean by here is node dot size, and this thing happens, then it exists. So that's another condition that we just got by doing this test. What do you mean AND operation cannot be? Oh yeah. Okay, so we are done. Hopefully this will work. Perfect. It works. So rank query works. Yes, I can say it with a guarantee now that it works, because we have checked whether the element is falling to the left or to the right. Things are going really well. What I've done here is just the randomized test case generation. I think I've taken, this was the very second video that I've taken on test case generation. One thing I can do is just to speed things up. I just close this now. Is to, what should I do? Yeah, where's the system.out.println statement again? Yeah, I'll just get rid of this guy. This should speed things up tremendously. This will also help me actually figure out if things are going as expected. Yes. So the reason why this works so fast, I mean, the process finished quickly, is we have 1,000 numbers. We have 10,000 as the bound, 1,000 tests. So this is just 1,000 queries on 1,000 numbers. All right. So if I do 10,000 now, it should technically still be very, very fast. So this is 10,000 Q, and what happened? Wonderful. Why? Element 10, left and right are what? Well, left and right of this, the element is 10. What have I done? I'm just increasing the number of tests. Yeah, I think I'll do that. And the bound has been increased, yes. Let's do this again. But this time with elements between value range 3 and n should be between 50. So let's see. So it does have an issue, it seems like. That's weird. So I'll just increase the bound to 10, and element ranges should increase. I'll just make them 100. There was an issue. Okay, well, 100, and the number of tests will increase a lot. I'll just increase the bound to 20, and everything else seems fine. So, okay, of course, I'm only checking element card. This is where the issue is. Who knows? Maybe there is an issue after all. Bound is 20. Right? Okay. Okay, maybe it wasn't working after all. Yep. There's an issue. All right, I'll just reduce the size now. This is 10. This is what's the length of this thing? A dot length 10. Yeah. So there was an issue between 4 and 5. Element 4 and 5. We have element number 16, which is not going to get stuff done. So element number 16 is not getting its stuff done. Simplifying further, we have element number 8. Element 8 not working between range 1 to 8. So this is what we have. Range 1 to 8. Element 8. That's weird. I can't. Oh yeah, I can see 1 8 here. So okay, okay. Hi Sandeep, what's up? Fine. I was just going through the comments again, and I was just checking if you guys have any suggestions. Language. Okay, C language. Fun World is saying that he's making videos on the C language, but views नहीं आ रहे हैं. That's fine. I mean, as long as you're able to help some people in C, it's quite good actually that you're actually doing this. Um, if you want more views, actually, you should probably be making cat videos. But if you want to really like have fun while you're coding, then yeah, then just go on doing what you like. That'll be nice, fun world. Now, getting back to the main problem, we have one element here, but for some strange reason this hasn't worked. So what I'm going to do is I'm again going to run through this algorithm, and I'm just going to again run this. So it will fail technically. Yes. So 0 is the count, the rank I'm getting, and 3 is the count that they are getting. So the between 8 and 8 is the query. So which is very good. Ah, yes, extremely good. Yes. Index for loop, yeah. So this is left, and this is right. This is equal to, and yeah. So now let's just run this. Even now it's wrong. Well, 1 and 2. So 2 to 6, 2 to 6, 2, 3, 4, 5, 6. This range, and what I need to do is I need to find the element 7. So this should occur twice. The count is correct here, and the rank is 1. So that's wrong. Why did that happen? Okay, so when I'm using this, I come to 1 less, right? I should be finding the number of sevens in this range, which is 0. And then I should be finding the number of sevens in this range, which is 2. And then basically my answer should be 2. So how is that even possibly wrong? So rank is right here. So I'm just going to print out right elements and left elements. Okay. Okay, right elements plus left elements. So this is 0. The answer should be 1, but it's giving us an answer of 0. Fine. Very, very, very odd. Why do we have an odd number of prints over here? Let's put this one. So the answer should be, just take another test case. Here's the thing. 1, 2, 3. Yeah, this makes sense. Okay, so 0 and 1. Now the rank should be, the rank is coming out to be 1, but the count is actually 0. It says between 3 to 7, find me the number of elements having value 2. So from 3 over here to 7. Over here, 3, 4, 5, 6, 7. Find me the values, elements having value 2. I am answering 1, and the answer should be 0. So why did that just happen? This is the range that we're looking at. 4, 5, 6, 7. In fact, 9 is also included. So I'm answering 1. Well, because between this range there should be 0, and this range there should be 1. No, in fact, this range there should be 1, and again this range there should be 1. So again, that's weird. So definitely the rank query is wrong. Or is it? Yeah, well, it is wrong. Let's just give it 0 to 3. Oh God, well, there are lots of issues in this. And I was hoping to actually complete rank and quantile and stuff. So what I'm going to do is I'm going to actually complete this by myself alone, because this needs some debugging, and it needs actually some deep debugging. I just tried a hack a few minutes ago, and that hasn't worked. And so what I'm going to try to do is actually just write down a library for this. I'm going to test that code and put it out in the previous 2 videos, and also in this video. I won't be saving this video probably because it's actually not helping anyone, because yeah, this code isn't working as expected. So I hope some general ideas were taken from this video, although the ideas are, you know, theoretically they are not working. But what I'm trying to say is some of the things like finding the pivot, getting the mapping, and these things are pretty important. So you see that there are fundamentally some flaws in this code, but the general idea is still the same: finding mappings and returning when you have leaf nodes. So guys, I apologize for actually not being able to code this out live. What I'm going to do next time is probably practice a few times before I go live, because although it seems better to go live with no practice and facing the issues that everyone faces the first time, it's actually it's not helping. It's not helping the people who are actually watching this. So what I'm going to do next time is practice, and then I will have some sample code to actually look at when I'm doing this. So thanks for watching, and thank you so much for your time. I'll just fix this code, and not just fix this code, I'll just also implement the other functions that we have talked about, quantile and range quanting, and be back as soon as possible with something new. So you can of course leave your comments on what you want new right here, or on the Facebook channel that I have. So until next time, then see you, and thanks. Okay, right, I'm stopping the broadcast.